done, but we wired up all the equipment. And all the equipment in the boiler room is fed from the same panel, which is located in the lower boiler room down there. So all the equipment all goes back to one panel boiler. And the equipment is all labeled. You see, every equipment will have a label which tells you what panel it comes from, the circuit number, and what the equipment is. And we can go through it if you want, but that's a general, description of what it says, what we have down here. Like I said, I am not instructing on anything because everything else was installed by others, and you'll be instructed on that after I'm done. Are there any questions on anything? That's really all there is on the electrical. I mean, if you want, I can go through, we can walk through and go through all the equipment.
What are these free drives for?
Those are the VFDs for the two pumps over here.
Well,
yeah.
We'll go through that with the HVAC, but...
Yeah, that's all part of HVAC, but... all I did is bring the feeds to all the equipment. So basically, I'm just telling you where the equipment is fed from, so if you get to service it, then you can check.
Just want the right heat on it, so the guys that might know what these are for too, night crew guys or weekend crew guys that come in, they're like, oh, this
says on
thing's in trouble, but we don't know what it goes to.
Okay. The pumps are labeled also with the same markings on it.
Where are the breakers?
Breakers are down here in the boiler room. We can take a walk down here.
Yeah.
Mechanical room, and I can show you the panel. Here's PVB, that gives you the circuit number. There's also a chart here. I also put like a little cheat sheet on the wall here, which lists all the equipment, the panel it comes from, where the panel is located, and what circuit number it is. So I gave you a cheat sheet, basically, in case this gets lost, or, and I made two of them, one up here and one on the other one. It'll be the same in building out, the same thing up there. So I just figured it'd be nice to have a cheat sheet.
Definitely is. Like I said, people take the cars and walk away.
Walk away from it, or if the tags fall off the equipment, at least you'll have a cheat sheet that hopefully stays there.
Put it in a picture frame. Yeah, those are regular ones,
Yeah, just regular. Just strips in the middle, shut it off and on. So the panel schedule in here. And I gave him a cheat sheet on there too that lists all the equipment, the panel, where it's located, which is right here, and the circuit numbers.
It's all boiler related?
Yes, it's all the boiler room located right in these.
I'll make copies of that and include that in the O&M.
I made two of them. I put one down here and I put one up top, on the wall up top. So
I just gotta put it up here.
Sure.
You can't see it from this side, but on the other side, the pipes come in, goes through an oil cooler, goes through the engine, also goes through this heat exchanger for the exhaust. It takes all the heat off the engine, manifolds, and the exhaust. Plus it generates electricity. It has it's just like a car engine. It has a battery, a starter, timing, just like a car. Tune up, just like a car. Lock the wires, cap, motors.
Batteries, I mean, they can go dead. Battery can go dead.
Oh, it can. I mean, yeah, but it has its own trickle charger in it. But they do go dead.
Yeah, well, that's what I'm saying.
And then you have the catalyst also for the emissions. You have a second stage, muffler. We have a stack going over there. Basically, you don't have to touch anything in here. If you see any water coming out, any oil coming out, just punch that red button and call me. I mean, if it's water coming out, just hit the emergency stop, give me a call, get active.
Emergency, what you do?
Yeah, if there's anything like oil pouring out and water coming out, if a hose bursts, anything like that, just kick that button and everything shuts off.
You guys hear that? Yeah. If oil or water's coming out, you just hit the red button.
These are the two isolation valves if it's leaking anything.
Yeah, these two right here. One up there, one down here. The control panel, you can push any button you want to look at anything you want. You're not going to affect anything unless you hit the stop button, obviously. The first screen, it just tells you the times, what the RPMs of the engine is, kW that it's at. That's the kW it's set for. And as you go through, you'll see the throttle percentage. That's the set point out for water temperature. The run time starts. That's all building related. That's all stuff that you monitor. That's the BT, the KWH. That's. You guys have something connected to this? Oh, okay. I don't know if there's anything connected to it or not. So that's like your customer information. We have this is the computer voltage, the battery voltage. This is also and then you have the date time. You want to change it. Scroll, arrow up, enter up, you can change it. Go over if you need to change it. You don't have to change it.
That's a little thing says 0 kilowatts right now.
Yeah, because it's not running. No, that's a fan. And then you have all your information for your voltages. That's the voltage on each leg, that's the average, the current, frequency. We have temperatures from the water in to the machine, the water out to the machine. That's coolant temperature is the temperature inside the engine. Like on your car, you have the oil temperature. The enclosure temperature is the temperature inside. When the covers are all on the inside the enclosure. These are all spares if you wanted to put other probes anywhere else. And then exhaust temperature, catalyst out, catalyst out. This is all custom information. You have then you have your emissions page, which is the O2 sensor, the bounce, the fuel valve position, the map. And then you have an alarm page. The alarm page saves, I think it's 14 alarms, tells you the time, the date it happened. If you have an alarm and you keep hitting reset, you're going to wipe all those alarms out. You only have one alarm. It's going to be all the same date, same time. Okay? So you're best off just calling me and I can come over and check it out. These are all the alarms we tested in my startup. But you can, if you want to come down here and look at any of these things while it's running, that's fine. You're not going to do anything.
It's not going to hurt.
If you don't know, just don't touch it, and it'll shut. The screen will go blank.
Yep.
And when you go back to it, it's going to be right on the first page.
This is the scroll button. What's that? Scroll button is how you access it. Scroll button.
And you can hit any button when it goes blank like that.
Yeah.
You can hit any button. Actually, just hit clear.
Yeah. Clear.
And it'll come up on this page like that, and then you can go if you want to look at
Scroll through.
any other alarm, any alarms, or what the last alarm was.
So the alarm light goes on when it's in low temperature fault?
It goes in alarm for a lot of things.
Right.
You have an oil level alarm, oil temperature alarm. There's also a thing called pre-alarms.
But when this thing is generating too much heat and it shuts off, is that also an alarm?
Yeah, it says low thermal power.
Low thermal,
Did you see it?
yeah. Right.
Low thermal power, meaning there's no load.
So when are we, and so that's normal operation.
Right.
When are we calling you?
When that red light turns red and it stays on, it doesn't blink, flash, nothing.
Okay.
It's like that. And you'll see the alarm.
Okay, so
on
it's a
there.
low thermal load, it's blinking?
Yes.
Okay.
Also a emissions fault alarm.
Will blink.
Pre-alarm, they call it.
Okay.
will blink. It'll flash like that. It'll say emissions alarm, but it'll still be running.
So solid red
Not
light.
a solid.
We're calling cogen.
Right.
T-cogen.
Do we, is he a sub for Mike?
What's that?
Under warranty, yes.
So do we call Mike or do we call him?
You. I think,
Find out.
Well, the contract's through Cam.
but his number's right on there.
Right.
I mean,
So-
my number's here. We take care. We have the
But
service contract.
Mike
with Cam.
also should be notified.
I would
Yeah.
probably say, I would probably say call Cam. Call Mike. Monte?
Yeah.
Yeah. I would say call him first.
Or the contractor.
And then he'll call me right away.
Yeah.
So you guys should
Or call both of us.
do who to call.
Call Mike and
Whether we
Mike.
call them, whether we call Mike, whether we call him.
Well, I think it's already
whether we
up on
call
those
all
lists.
Three.
I mean, that's not, I think Mike's supposed to be here in a little while.
Yeah, he'll be here in half
Just
an
ask
hour.
him what he wants. I mean, you can call me direct. That's my cell phone number.
Right, those sheets are updated.
No.
So,
You lose power.
I think the sheet saves contact Mike.
Yeah.
Or, you know,
That's why
Bob,
I'm asking.
Mike.
'Cause they-
Yeah.
No,
But yeah, we can't get a hold of him, we'll call him. But there's gonna be a
Without the
pecking
power,
order.
it's off.
A brief overview on the design of the system. You have 4 boilers and you have a generator, okay, or a cogen. And the cogen is considered boiler plant number 1, and then your boilers kick in 2, 3, 4, and 5. The boilers are marked 1 through 4, okay. The cogen is marked CG1. Don't get confused, because the cogen is actually boiler number 1 when we get to the control layout on the Viessmann cascade controller. Okay, what we do is the boiler does, the heating plant does 2 different things. It heats the domestic hot water, which is behind me, and it also heats all the heating water for the building. Okay, it has a reset program in it, so the heating pipe temperature is not always the same. It offsets according to what the outside air temperature is. We have independent pumps for each one of the appliances, meaning the cogen, and each one of the boilers has its own pump to force water through that appliance. And then the building main heating pumps are over on the other side. You'll see those are the big 7.5 horsepower Taco pumps that are on the floor. Okay, those circulate the water out to the buildings. All of the buildings have their own isolation valves. Okay, those are branched off the mains and those are balanced accordingly. The cogen water does not mix with the building heating water. It's its own fluid. It's done through a plate heat exchanger, which is located behind you right there. Anybody confused or have any questions about just the basic design of the heating plant? No? All right. I'm going to start by taking you guys through the main building heat drives. These are pumps 3 and 4, okay? What we have is we have a VFD, which is a variable frequency drive. When you open it up, kill the power, turn the drive off, 3 latches, the door will open. You notice there's a circuit breaker here. This is a resettable circuit breaker. There are fuses on the step-down transformers, okay? And there is a manual reset overload if you ever have to put the drive in bypass, which you should seldom, if never have to do unless something goes catastrophically wrong in the drive, okay? The drive gets commanded on through the building controls. There's a lead lag program on the drives. It's located over here. About water pumps as part of the TechMark control. That'll be going over with your control contract later on. Things of service on the drives. Once a year, somebody should come in, kill the incoming power to the drive at the circuit breaker panel. Check to make sure all the electrical connections are tight, they're in good shape. Check for any scoring, any tarnishing, marking, any arcing, things like that. Other than that, there's nothing else in here that needs to be done. The can blow it out with compressed air while it's not running. This is a mechanical space. It does have a ventilation fan located in the top of it. For no reason should you ever store anything on top of these drives, in front of them, next to them. They do not operate well when they get hot. Okay, they have to be in a well-ventilated area. All right, I'm going to close this out.
Can you just show what the reset was again?
Down underneath the bypass contactor, there is an overload, and it is a resettable overload. The red button. The red button. It trips, you reset it. For no reason should you ever make any adjustments to what's already here. Okay? Trip and reset.
So what are the normal ranges?
Okay. What we do, and this is part of your control layout, okay, is all the apartments have fan coils in them. All the fan coils have zone valves in them. The pumps are designed so that all the valves are open. The valves start getting satisfied and the heat satisfied in the apartments, the valves start closing down. You don't need the full capacity of the pump. So the pump starts to ramp down. That's done through the BMS system. The range on what you're seeing for a readout is actually how many hertz the motor is running at right now. That's how much is needed to maintain a 13 or 14 pound differential. 13 pound differential on the pumps. Okay, if the zone valves start closing down, suction pressure starts going, the low side of the pump starts going down, the high side of the pump discharge starts going up. So now your differential starts climbing. What our differential sensor does is says we've got too much water flow. This piping's starting to get restricted. So they start slowing the pump down so we can maintain the same amount of water flow no matter how many valves are open and how many valves are closed. Okay? And there are a couple of things that you cannot adjust on these that are factory set. Meaning the high frequency, what the maximum allowable frequency output is on the drive, that gets you your design GPMs, and then there's a low limit frequency. Okay? Motors on variable frequency drives do not like running down below a certain RPMs or a certain amperage. You drop down below that, the drive trips out, and then you've got a nuisance call, you got to come in and reset it. So this has a 15 hertz minimum command. So anytime the drive is called on, we run the pump set, it's usually 15 hertz. That way the motor protection works and everything. And then it'll ramp up and down according to what the set point is on the DP sensor. Again, your control contractor is going to go over that with you later. Now, for some reason your control system crashes or something malfunctions and you need pumps, and you need to run pumps, there is the ability to bypass the pump. Okay? You can put it in bypass and the pump goes to 60 hertz right away. It stays there, it doesn't move. Not a good idea. Now, if you just saw what I did, you heard the other motor start to slow down. It's because when I put this in bypass, I ran the differential way up. So what happened was the drive started compensating and shutting this drive down. When I turned it off, it came back up. Now it's going to hunt a little bit until it settles out. That's a normal occurrence. If you want to run the drive, you want to run the pump on the drive but not through the control system, that can be done also. You put the drive in manual, which is a local remote button. The green indicator lights will come on, the run light will come on, and the green indicator light next to the up and down arrow will come on too. I can adjust the speed of this drive right now without the control system. You can hear the motor turning down. 15 hertz, that's your low limit. I'll put it back up to 36. You hear the drive come back up. If you ever have to put this drive in the local control mode, it needs to be monitored. You can blow the pump. Okay, so if you put this in local, you turn it up to 40 or 50 hertz, you You walk away thinking, that's all we need to do, we'll call the vendor. That's not the case, because if the zone valves start closing down, if the differential gets too high, you can do damage to the internal parts inside the pump. You could blow the seal, you could take out a bearing, you could create excessive noise in the system. You could have zone valves that will refuse to open up because the pressure is too great on the high pressure side of the valve. Okay.
What are safe, if they're looking at the differential pressures, at what point should they be worried?
Well, if you're, the system's based on like a 14-pound differential pressure. If you're upwards of like 18 to 20, you got to start getting concerned. If it goes higher than that, you really got to be concerned. Something's going on. Either somebody shut a valve, something got plugged up.
So what should we do right away if that happens?
Look at the DP, see what the drive's doing. Just make sure the drive is under its own control. Nobody's bypassed anything. Just the obvious first, then you would investigate the piping system, okay? See if perhaps there's a plugged strainer.
And we're not shutting nothing down, we're just watching it and letting somebody know there's something going on.
You're marking,
Like you said 15 pounds, 14 pounds.
this is the VFD, it's 15, and the bypass valve is set for like 13. Okay, do a bypass valve too. The control vendor, the control guy's gonna go over all that with you later. All right, he's gonna be the one to quote on this. Okay, you do have your inverter and bypass switch here, so you can run it on the inverter. If the inverter crashes, you can bypass it. But again, like I said, you gotta be careful what you're doing when you're running a bypass. Okay, you gotta know what the rest of the building systems are doing at that time, and just keep an eye. You don't want to blow a pump up because you hit the switch and walk away. Okay. Any questions on the drives?
Blowing up pumps is bad.
Yeah. Damaging pumps is a very expensive thing. Okay. Before I turn this over to the boiler representative, sorry?
We have it the other way first?
This was off. I had it off.
Right.
This is the switch for the bypass and the inverter. I'm going to put it back on the inverter. If one pump fails, the control system senses that, it turns the other pump on, okay? We're going to go over the pumps real quick, and then I'm going to let Kevin be. Okay. Your isolation valves here. There's a check valve and a balancing valve located above it. There's a suction diverter down in here. Periodically, every couple of years, you're going to pull this out, clean it, put it back in. Of course, you're going to isolate it first, kill the pump, isolate the valve, pull out the diffuser, clean it up, put it back in, inspect it for any debris that might have migrated in. If something you know is not supposed to be there, you make a phone call. Okay? Very odd that you would find anything in there. Sometimes on older systems you'll find rubber seats for old control valves, things like that, caught up in the piping. Eventually it makes its way back. If you keep these clean, you'll have great flow throughout the facility. Pumps themselves, underneath the safety cover. Okay, you take off these two nuts, slide this guard forward, and you'll find a zerk fitting right there. Pop your grease gun on, a couple of squirts of grease. Don't start pumping it until you see grease coming out of the motor. It's not a good thing to do. That just means you ruin the seal in the bearing. You want to give it just enough grease where you feel some resistance on the grease gun, and that's it.
That's every 2 months.
I would check it every 6 months. Every 6. I mean, in the wintertime, there's going to be obvious telltale signs that you've got a problem. You hear the motor making noise. You'll get some vibration, things like that. Running hours is another thing that you would have to look at. These pumps come on when the outside air temperature drops below a certain set point. And I believe it's 70 degrees, 65 or 70 degrees, and then the pumps come on. Okay.
Basically once a year.
So I would do it at the beginning of the
It's not running in
season.
the summer, right?
Well, you can't always say that because some summer evenings the temperature does go down low enough for the heating system to kick on. So I would do it at the beginning of the heating season, about midway through, okay, or 2/3 of the way through. Then you're gonna know you're okay. Obviously, if you put the grease gun on and you go to pump it and you're feeling a lot of resistance, don't try to force things in there. It's not meant for that, okay? Keep the area clean. You should never see water dripping out of it. It's a dry system, on the outside anyway. Very important to keep the safety covers on. They're there for your protection, okay? Don't close any valves unless you know that you've got the pump off. Make sure you open the valves back up before you turn the pump back on. Any questions?
So, on, I've got your monthly and annual maintenance.
Sorry?
I've got your monthly and annual maintenance
Yep.
schedule.
Yep.
Check suction gauge reading and confirm that it's normal.
Yeah.
What's that? What's
Yeah.
normal?
You're gonna look at your gauge readings. You have one on the inlet of the suction. You have another one on the outlet of the pump over here. You just look to make sure you've got enough water in the system, number one. If you don't, the system usually going to shut itself down. Water safety is built in, so no pressure. Okay?
So what's a normal range?
Well, it actually depends on how much lift you got. When the system's sitting dormant, you should see between 18 and 20 pounds in the system. Maybe a little more, 22, 25. You get down to like 15, you got a problem. Okay? There is an autofill on this system. I'll show you that later on after Kevin does this thing. All right?
What are they running this system, like 20?
Yeah, about that, because you're looking at 3 stories, and we're already on the first level pretty much. So we're not trying to push that high. Any other questions? Nope. Okay. I think the PRV is set more like around 20. I work for Viessmann Manufacturing. So my goal today is just to go over, give you a brief overview on sort of what we're looking at here in the building for boilers and for a system. So as you can see here, we've got 3 boilers down here and 1 up there. The only reason for the separation is space. As you can see, we can't fit us in here, never mind another boiler. That's the only reason that boiler 4 is actually up and away in the other room. They all function together in the same system. So our lead boiler is down here. The lead boiler is the one that has the system control on it. So probably better to focus down on this room than up in the other room. So what we're looking at, the 4 boilers that we have here today are gas-fired condensing boilers. So a condensing boiler is different than a conventional boiler that you may have had here in the past. So conventional boilers, you'd have a fire inside the firebox. The flame would heat up the casting, the flue gases would go through that casting and up and out the chimney, and you'd have exit flue gas temperatures somewhere in the 3, 4, 5, 6, 7, 800 degree range, depending on how efficient or non-efficient the boilers were. These boilers are a little bit different. What we try and do is cool down those flue gas temperatures, because if we can get the flue gas temperatures down below, say, 130 degrees, we start to turn that water vapor that was normally a steam back into a liquid, and we can reclaim some of the heat off of those flue gases and put it back into heating the boiler. So instead of having a boiler that's somewhere in the 80 to 85% range at best, these boilers will operate somewhere in the 90, 95, 96% range, depending on what sort of water temperature that they're running at. Now, how do we cool off the flue gas temperatures going up the stack? Anybody ever guess? You didn't know there was going to be a test, did you? So as a return water temperature comes back from the system, it's given up all the heat to the baseboard, to the radiators in the building, it comes back to the boilers a little bit cooler. So that cooler water temperature is what actually cools off the flue gas temperatures. So ideally, you want to have water temperatures coming back to the boilers at lower than 130 degrees, because that's the only way you're going to cool the flue gas temperatures off below 130 degrees. So the cooler the water temperatures are in the system, the higher your efficiency is going to be. So that's why you'll see peak efficiencies or higher efficiencies in your shoulder seasons, or a day like today, even though we're in the middle of the beginning of March, we're still at 40, 50 degree temperatures outside.
So at the higher temperatures outside, that's when you'll see your higher efficiencies in the boilers inside. Now this system is a little bit different. That we have, in addition to the 4 boilers, we've also got a cogeneration system outside giving some supplemental heat to the building as well. And that is actually being enabled and disabled for a call for heat from our main boiler control. And what you'll see, some of you that are in front of the boiler control down there, you'll see boilers number 1 through 5. When you look at the boilers, you're only seeing 4 Viessmann boilers. One of the boilers that are showing up on our screen is actually the cogen plant that's outside. And in this case, that cogen boiler, cogen system has been configured as boiler number 2 in this package. What's that? Well, I'll explain. So as far as our system knows, it's boiler 2. We've set up boiler 2 in our system to always be the lead boiler. Okay? I couldn't make it boiler 1 because boiler 1 has to have the cascade control on it. Oh, so that's the reason for the number.
Even though it's boiler 2, it's first stage heat.
Right. So all we've done is program boiler 2, which is your cogen system, to be the lead boiler all the time. So that one comes on first.
If you didn't have the cogen, it would be boiler 1.
Boiler 1 would be boiler 1. So if you look at our system, it's still labeled as boiler 1. So if you see the boiler 1 tag on our control, it's still reading our boiler 1. If you open this control here, even though the jacket panel on the front of the thing has a label that says boiler 2, the screen actually says boiler 3. So realistically, you've got 1, 3, 4, and 5 up top, and boiler 2 is actually the cogen system on top. Right? So after the lead boiler has run and either gotten the temperature up to where it's supposed to be or not satisfied the load, the next boilers will start to come on in a cascade fashion. So that's the one thing, if you're watching these boilers and you're thinking they're going to operate like your typical boilers, this is the one thing that's a little bit different with condensing boilers. Because it's more efficient to run condensing boilers at a lower input, you may come down here on a mild day and see 2, 3, or 4 boilers running. The difference is that they're running at low fire potentially. So the way that the other 4 boilers will stage and rotate is that if the cogen system is not keeping up with the load and we have to energize the Viessmann system, the lead Viessmann boiler will come on. If it hits 60% of its full input, it'll actually drop down to 30% and then pull on the next boiler, and they'll modulate up and down together. If those 2 boilers hit 60%, both of those drop down to 30% and then pull on the next one, and so on and so forth. And we can do this with our control package up to 8 boilers. So that's the one thing you want to keep in mind. If you come down here on a mild day and you say something's wrong with the system, all of these boilers are running, and it's only 40 degrees outside, that's why. And that's going to be different than what you're used to in a typical stage boiler system. The other thing you want to keep in mind about condensing boilers is you've got one other thing that's different than you'd have on a normal boiler, and that's around back. We can't all probably file in around back, but you'll see on the back of the boilers, there's a little black box on the back of the boiler with a hose connected. The back of each boiler, the boiler upstairs has one as well, and that's a condensate neutralizer. So when we've cooled that steam back into a liquid, we get water, right? That comes down the flue gas, that comes down the chimney, and also comes out the boiler because we've condensed that water vapor back into a liquid. The problem is that water, because it comes from the byproducts of combustion, becomes a very aggressive water. It has a very low pH. So we want to run that water through this condensate neutralizer to raise the pH so it's safe to put back into our drainage system, our septic system, or our city sewer system. Okay.
Those will be cleaned out too?
What's that?
You get clean those out?
So I'm going to show you. So all of these come off pretty easily. There's 2 little white clips, and the top cover comes off. So it's not magic inside. What you have inside is a box full of lime pellets, a bunch of little rocks made out of lime to fill up that condensate neutralizer. So they don't, as we say, they don't go bad, they just go away. After a while, those lime pellets will begin to dissolve. Now, the one thing that you want to be careful of is what you see here. So over time, depending on what we're sucking in for combustion air and things like that, you'll start to get dirt and sludge collecting on those lime pellets. Now, it's not going to hurt the operation of the boiler. The problem is if there's a coating on those lime pellets, it prevents the lime pellets from neutralizing the condensate. So part of your preventative maintenance service every year, you want to make sure that somebody is monitoring the lime pellets. You can take them out of there, put them in a big spaghetti colander, hose the sludge off, put the lime pellets back in. Over time, you'll see those lime pellets start to dissolve, and then you fill the lime pellets back up. That'll take usually a few years anyway. Okay? But the important part is making sure you keep that brown sludge off of it, because that'll stop the lime pellets from neutralizing the condensate.
This one's obviously
This one could use a service. And that's the hard part, when the building's under construction and all the work that's going on, you're sucking in dust and debris and dirt, and you've got excavation going on outside, and you're sucking in all that stuff, okay? So this is not out of the ordinary, this is common to see on a job like this. You just want to make sure you monitor that every time you do a preventative maintenance service.
So in the Viessmann preventative maintenance literature, it says to check the pH of the condensate.
Yeah, and that's not so important on the boiler side, but you want to check it if you want to check it coming out of this condensate neutralizer, especially if you have cast iron soil pipe in the building for drainage. Because if you have a low pH going in that cast iron drainage system, you'll start to rot away the cast iron over time. Now, if you're in I know we don't have the issue here, if you're in a building that has a septic system and you're dumping that low pH into a septic system, you actually kill the bacteria in the septic system and you stop the bacteria from doing its job. So it's important to make sure that we're neutralizing it. If you come in here and the lime pellets are nice and white and clean and they're full, you shouldn't have any issue with the right amount of pH coming out the other side.
When they're like that, what's the site staff do?
You can take them out. There's just little lime pellets. You can scoop them out. I say put them in a big spaghetti colander, hose them off, get all the sludge off, and put them, just pour it back in. Yeah.
Is that water dangerous?
No, I mean, you want to drink it.
No, I mean,
Not gonna hurt you. Not at all.
How often do you want to check those?
Every time you're going to do preventative maintenance, whatever your schedule is for that, whether it's a year or 2 years. You're not going to find it this way very often. It's just now during construction it tends to get dirty. So George, what's your typical PM schedule?
PM schedule once a year.
Yeah.
The guys come in every day and they do.
You don't need to check it
No,
once a year. And the covers all come off pretty easily, so it's,
I would actually, typically, how much for this pellets to dissolve?
it depends on the temperature system that you're running. The lower the temperature system, the more condensate you're going to produce, the more you're going to dissolve the lime pellets. My guess here is you're good for 4 or 5 years before you have to replace it.
And then if we clean those out, this is muddy, clean it out, add, top it up.
I think you got enough there. I don't think you've dissolved much
If
yet.
it was lower, you
Yeah.
top it up.
When that does dissolve, you have to go with the same style pellets in there, and you use limestone.
You should be able to use limestone. It'll take up, it'll take up
Small chips.
You'll probably get more utilization out of this because it fills up the box a little bit better. We have the
Surface
replacement
area.
bags. If you're looking for them, we've got the replacement bag. And I think we typically, Tom, did we send extra pellets for the job, Tom?
I don't know. Which we not usually, because sometimes people go in the Home Depot and get a limestone box.
Yeah.
Or is it okay? They're bigger than they're like 340.
Yeah,
So they've got less surface area to dissolve more acid.
So the bigger and more jagged they are, the less you can fit in the box.
So let's just fit the box. You see yours right now, once you get this mudded up like this, we almost expect to probably one more.
Pouring it back in. Yeah, it'll come out the other side. It shouldn't overflow.
Smaller rocks.
All the boilers, except for boiler 1, you'll see what that individual boiler is doing. So if we look here, this one is a second boiler in line, but it's boiler number 3 as far as our control knows. You'll see that it's firing because there's a little flame in the window. So that boiler is actually running. You'll see that it's running at about 144 degrees, and its output right now is about 297,000 BTUs. Okay, so it'll give you the modulation point, it'll give you the temperature that it's running at. If you look down at boiler 1, the thing that differs is you see what all the boilers are doing. If you look at boiler 1, boiler 1 is down here. Boiler 1 has actually become the last boiler in line. And boiler 2 is firing at full input. We don't know the modulation of the cogen, it just has an on or off. And then you can see sort of the modulation range of all the other boilers in the row.
this is actually true.
It changes. So let me talk about how these rotate. The only one that stays the lead boiler all the time is a cogen system. The other 4 boilers will rotate on a monthly basis. At the first day of every month, the system looks at the burners with the least amount of run hours, and that becomes the lead boiler for the following month. So we get equal wear and tear on each of the boilers. So you can set that up by run hour, you can set it up all different ways. The easiest way for us has always been that at the first of every month, we look at the boiler with the least amount of run hours and we make that the lead boiler. So you may come back next month and number 3 is all the way on the other side of the road. Okay? Now if any one of these lock out or have a burner failure or something like that, it will become out of rotation. The next boiler in line will step up and be the next boiler in line until you solve that problem. Okay? So let's talk about faults for a minute. if you have a burner failure or a fault, or somebody knocks the outdoor sensor off the side of the building or knocks one of the supply sensors off the pipe, you will get a fault in the system and it will show up everywhere. The first place it shows up is on the boiler itself that has a fault, but that'll also get communicated back to this control here, okay? And it'll be a plain text fault. It'll tell you that the fault is either with participant 2, which in this case is, or participant 3, which in this case is boiler 3. It may tell you that it's simply an outdoor sensor fault. It may tell you that it's a burner lockout fault, and it'll tell you exactly what that burner lockout failure is. So what I would ask you all to do, if you're down here at that time when you see a fault, before you hit a reset button, before you turn something on or off, either take a mental note of what that note is, write it down, what that fault is, take a picture with your smartphone, and just save that. So at least when you call Tom or call us or call somebody to figure out what the problem is, we have a starting point and we can diagnose the problem a little bit better. So before you hit the reset button on anything, at least take a note of what that lockout failure or what that fault alarm is. Okay. Now let's see if we can take a look at that.
So Kevin, just double check. This is the code.
Doesn't do anything in the kitchen. Yeah, it just tells you what the
This number one, no, that one, give it to
so
Kevin.
you can look at the individual boiler. There's other ways to go into here and see what each boiler is doing. We'll talk about that here. Let's take one of the covers off. Let's make even less room for all of it. So, underneath that front cover, we see a couple of things. First, the burner itself, the gas valve is a low pressure gas switch if you have low pressure issues, and you have the burner's flame safeguard control. Now, we used to have a little opening on the front jacket panel so you could see this, so you could see any faults that come up here, but they now get transferred from here up to the main control, so you don't need to see this. However, the reset button is on this control if you have a burner lockout. A little red button with the letter R on it, that is your burner reset button. So you'll have a burner fault here, but it'll also show up on the boiler, on the burner up top. If you have a low pressure situation, you'll have a fault that shows up that tells you external safety. Here's your low pressure switch. It's a manual reset low pressure switch. It's just pushing it in if you think you have a low pressure issue. The other thing that could cause that same problem is a lower to cutoff. There's a reset button on a lower to cutoff as well. But both of those will show up as faults on the control itself. Okay? But that's the main thing. You're not going to be able to reset it from up here. You'll have to take that front jacket panel off and hit the reset button there. Okay. You'll see our fresh air intake hose. It goes to the back of the boiler and connects to your air intake if there is one, or it just draws room air from the back of the boiler. Okay. Any questions so far? Probably a bunch. Because it's a smooth wall stainless steel heat exchanger, it's a single pass heat exchanger. There's no clean out covers that have to come off for maintenance or for cleaning. This burner door opens up like a cabinet door. So you have a gas union connection on there, you break the gas union connection. There's 4 bolts in the 4 corners on the burner door. You unplug some of the cables and now this whole burner door with a burner on it swings right open. So how do you clean it? You get a garden hose. There's a garden hose somewhere in the building you can connect to. You spray the inside of the chamber down with a garden hose. If you see any buildup of dust or debris on it, all that water will run down out through the condensate drain and out the back of the boiler. Okay? Very easy boiler to service and maintain. You don't have to take the burner off to get at the electrodes or the ionization rods. Everything is pretty accessible. That comes off as well.
Break this union.
Yep.
And then the whole thing comes out.
The whole door will
You
swing. Yeah, you can leave the gas stuff there.
Do you mind if I go through some of the maintenance items from the O&M manual? Chest pressure relief valve and check the proper operation.
Yep.
So how do you test the pressure relief valve, Kevin?
You open it, right? So the pressure relief valve is on top of the header, right near the low water cutoff on each of the boilers. And the only way to test it is to open it, make sure it relieves, and let it close again.
But because when you open the pressure, we can't get it to shut down. So we don't do it. So that's something we don't do, Joe.
So we shouldn't be doing that? Why is it in your
Well, the
manual?
point
It's
is,
in every boiler manufacturer's
the
manual.
Board of Inspection tells us, he's gone with John and Jimmy before, he says, I want you to test the pressure. We said to him, John said to him, listen, this is over the winter. if I can't get this shut off, we're gonna lose it. We're gonna lose it. So we don't typically do that. I'm just telling you
No,
every time, so that the expectation is that we're gonna do that. We're gonna pop the relief valve every time, you know, once a month or once every week. We're not gonna do that. If it leaks, we replace it.
Yeah. Well, it's a hard to the part. You get a little sludge or sediment underneath that seat and all the cells completely.
I'm not sure if some of this is stuff that Viessmann techs would do.
Common supply sensors in our system. One handles what I call the boiler loop. The other one handles your building loop, your heating loop. So the boiler loop sensor is here. So this is monitoring what our common supply temperature is from our boilers. Now, in this building, we're a little bit different. We leave the boiler room and then we go through a mixing valve that tempers that water down to go out to your individual heating system for the building. Whether it's, I don't know, is it baseboard, radiators? What do we have in the individual? Fan coil. Fan coil. So we have a mixing valve that tempers down the water going out to the fan coils, and there's another common supply sensor there monitoring that temperature. Now, ideally, we keep this loop about 15 degrees hotter than the supply set point of the building loop. That's only to make sure we have enough temperature there to mix. The only time that changes is when there's a call for domestic hot water. Then the boilers ramp up, and the mixing valve will actually begin to close down, so you still don't send out that 180 degrees to the building loop. There's no need to send that out there and have standby loss in the piping. So you'll have one common supply sensor here and one outside of the mixing valve. The domestic hot water system comes off the boiler system before the mixing valve, so you're not sending mixed temperature out to the domestic hot water system. Okay.
There's a problem in the water temperature too cold. How do they adjust the reset program?
The curve. I can show that. So George wants to go over the controls. So George, why don't you try it? Okay. So as soon as you hit that screen anywhere, you'll see a menu button pop up in the top left. No, it's the top left. Right. So if we want to adjust the heating curve, if we want to adjust the temperature of the heating, where would you think we would go? Yep. So for heating circuit number 2, you want it is your heating system. So let's say heating circuit 2, that's your fixed temperature. You should see something there that says heating curve. You may have to go over to the right, so you can see that right arrow here. Okay. So the heating curve button. So now, this heating curve is your heating curve chart. So on the bottom row, you'll see your outdoor temperature. On the side row here, the left-hand row, you'll see your boiler water temperature, and this is the curve that you pick. So now, the way we're set up now, you'll see that at about 14-degree outdoor temperature, the boiler is going to run at about 140 degrees. Okay? If you find that that's not where you want it to be, you want it warmer or colder, you can actually adjust these two numbers. Now, you don't really have to care what those numbers mean, because as soon as you start to touch them, you'll see that curve shift up or down. So you get that to the temperature you think you want based on your outdoor temperature. You get it at a 0.7. And once you get it to where you want it, you hit the OK button. Okay? Now you can go back to the main screen if you want, or eventually it'll go back to the main screen on its own.
So now, shift.
Yeah.
Shift and slope are the same?
So the slope is the pitch of the curve. So you have two different things. You have the heating curve, which is this line here. Now the lower that number becomes, the flatter that curve is. If you had a 2.0 heating curve, that would be a pretty steep hill. So you can actually now pick a flat curve, and with a shift, you can shift that curve up and down the aisle anywhere, or up and down the row anywhere you want.
Okay. So you shifted the whole thing up?
Yes.
It's the same.
So the steepness will stay the same if you don't change the slope, but it'll shift that up and down. Yep. George, you mentioned how do we see what the other boilers are doing from this control?
Yeah.
So let's go back to hit the home button again. Go back to the menu. And you see the service.
Yeah.
So now the control is going to ask you for a password.
Okay.
And your test for today is to remember the password. Everybody ready?
No.
VI Master. That's a password that will get you into everything.
Oh, it's written down.
So you don't even have to remember it. Tom must have written it down.
Yeah, it's on.
That's no. Capital? Master?
No. That's VI Master. All one word. And that'll get you into every last bit of coding. But now because I've given you that password, if you get in there and you screw something up, it's your fault. Now you can see diagnosis, top left. And if you want to monitor what the system is doing, you have a menu there that tells you. So if you want to see what heating circuit, what your building, what your heating loop is doing, you hit that and you can scroll down, you'll see all the temperatures of your heating system. Your common supply temperature, your common supply set point.
So this is what my set point is for my room, that's my potential heat.
That's where the room temperature set point is set. It's the basis that becomes your warm weather shutdown temperature as well.
Okay.
You can't get that screen by just throwing in information.
You can, you won't get as many, you won't get as much information. You'll get what the actuals are, but you won't see what the set points are. Yep. You can do the back one. Now you can look at your domestic hot water temperatures and see what they are. Right now the temperature set point is 134. The actual domestic hot water temperature is 131 in Klein.
So I can get the domestic hot water temperature and the heat temperature is relieved.
Yes. And you can raise the domestic hot water temperature on this control.
Some people, when I'm naming for domestic one, is there a set point for the single systems?
Yeah.
That pump is to pull water out of the header, force it through the boiler, and back out into the header in order to supply the three-way valve with hot water. There are grease fittings on the pumps, okay? Every 6 months, check the grease, okay? A lot of maintenance schedules will tell you, check it every month, check it every month. Well, you can start out by doing that. But if you don't see excessive wear, or if you don't see the pump start chewing through grease, you can delay those maintenance checks out further. I say the same thing to customers when it comes to filters, air filters. We'll tell you to change them 4 times a year. But if you're going in 4 times a year and 3 times, twice a year, pulling out clean filters, cut one of your PMs down and stretch them out, okay? You're going to want to inspect the pumps every 6 months. Just get up, make sure there's no debris around them, blow them out if they're dirty, check the grease, electrical fittings, things like that. Each one of the pumps has its own starter, okay? The boiler tells its pump when to turn on. So in the back of the boiler, there's a pump relay box. That tells this pump to turn on. Right now, boiler number 3 and boiler number 2 are running and heating because the indicator light's on, okay? There are HOA switches on there. If you feel that the boiler's not turning the pump on or the boiler's tripping out on high temperature because there's something wrong, okay? Usually, you reset the starter, okay? If you can't reset, does anybody have a screwdriver on them? No? So inside each one of the pumps, pump starters, there's an overload, there's a reset plunger for the pump. These are single phase, but you'll see 3 heaters in them. All starters are 3 phase until you get to the starter switches, which are very small. So what happens is power comes in through 2 of the legs. One of the legs circles up through the other heater in order to complete the heater circuit, okay? There are 2 sources of power for this. One is power from the pump itself. The other is the signal power from the boiler. It's 110 volts from the boiler to engage the starter. Don't think that by turning the breaker off from the panel that you've killed this starter. You have to kill the boiler and you have to kill the pump power in order to work on this, okay? Because one thing tells the other to run. The pump breaker is for protection of the pump. Control power for the starter comes from the boiler. That's important to know.
Does it say that on there? Does it say 2 sources of power?
No, it doesn't. No, it doesn't. It's the same thing as having a transformer in a building that does all your controls, but your appliance still has its own power. It's the same premise of design. Okay. Maintenance on this, again, just make sure all the screws are tight. Electrical connections, things like that. You don't want to store things on or above this, around it. Keep it free and clear so you can get access to it. You'll see it's got HOA switches, okay? Let's say the boiler's firing, and you come in and it's locked out on high temperature. First thing you're gonna check is to see if that pump's any good, okay? You hit the hand button, see if the pump starts. If the pump doesn't start, then the overload's probably tripped. You're gonna wanna reset the overload, pump in the off position, reset, return it to auto, reset your boiler, watch it fire up. If you don't feel like waiting, you can push the hand button just to make sure the pump fires up. Now you know it's not a problem with the pump. Put it back in auto, reset your boiler, fire it up, and then make sure the pump comes on, okay? I don't know if Kevin went over anything else on the boilers. The boilers also have low water cutoff controls on them. Did he mention that? Okay. On the top of each one of the boilers, you'll see a cross T. On that T, there is an automatic vent that vents any residual air that gets in the boiler. That's a low water cutoff. On the side, same low water cutoff you'd see on any residential or like commercial boiler. Okay. It's got a test and reset button on it. If you walk up to the boiler and there's no power to the boiler, okay, no power to the burner, right here, this display is off, but you see power on the boiler, control panel, and an alarm, generally means you trip the low water cutoff. If you do trip that low water cutoff, you can reset it. If it doesn't reset, that means there's an air pocket in there. Two ways to get that out of there.
Is that a red
One is,
light on it on the other side? Like
yes,
just like
just like you would
at my house.
and your green light and a red light.
Yeah.
Now, if you have an air pocket in there, which has happened, okay, one or two things is wrong, okay? Well, there's only one thing wrong. You got air in that cross, which means the vent's plugged. On older systems, it's not uncommon. I have run into that problem once or twice before here. It's because we're retrofitting onto an existing system. We're using some of the older appliances. We're still not done. So you might get an instance where you get a plug vent. You can clean them, all right? It's not that hard to do. Isolate the boiler at the top, 2 valve isolation valves. There's a boiler drain on the back of the boiler. Relieve the pressure on it. Then you can unscrew that vent, okay? Take the vent off, take it to a faucet, rinse it out, shake it out. You'll see mud coming out of it until we're done with the entire project. And then put it back on, open the valves, you'll hear it aspirate until all the air's gone. Refire the boiler and you should be fine, okay? Did Kevin show you the low gas pressure switch? He did? Okay. So you know about all the controls in here. Again, one of the most important things is if you walk up to the boiler and you're working on the boiler, take pictures of what you find. If you want to make an adjustment to the boiler, like the heating curve or something, take a picture of that heating curve before you adjust it. Because in 2 days, you're never going to remember what it was before you touched it. You'll know what it is afterwards, but you won't know where you started from, okay? Some of the things that aren't covered under the warranty are things like that. If we come up and we have to readjust things because people touch them, it's not covered under warranty. If we have to come up because somebody pushed the off button on a pump, that's operator error. If it's in auto and the pump goes bad, you're covered under the warranty, okay? But you just make sure that before you call us, you just make sure you've done your diligence on a few things. Make sure the breakers are on. Make sure nobody's turning the switches off. Make sure none of the fuses are blown, okay? We won't cover a blown fuse unless there's a part that blew the fuse. There are peripheral things that can cause nuisance problems within the system, i.e. the utility company's working. You know how many times I've been called out in the middle of January because there's low gas pressure at the street, and I'm resetting boilers and leaving, coming back the next night, resetting it again, then I put a manometer on it and find out you don't have adequate gas pressure, okay? So things like that, you know, where the utility company's working outside and they interrupted the building power and tripped all the high limits because the boilers were in high fire when they shut the power off. So temperature went up, limits opened up, they didn't reset on their own. These boilers all have resettable high limits, okay? If not, they can be done through the front display. Domestic hot water. The boilers control the domestic hot water. Over on the wall over here are your 2 zone pumps. You take the boiler water and send it over to the heat exchangers in the domestic hot water tanks. Okay? They only run when there's a call for domestic hot water. I tripped that out by hitting the starters are marked here, DWH, shut it down. Okay, it was in alarm. Okay? This is something that your control vendors can go over with you once we're done. Okay? Maintenance on those pumps, there is none. Those are maintenance-free motors. You basically just have to make sure they're kept clean. Okay? Over here, we have your pressure reducing valve, which is your water makeup for the system. All right? So this is set at around 23 to 25 pounds. So if for some reason the system needs water, it'll make it up on its own. If it has to make up water all the time, you get a problem. Don't be surprised if this is reading higher than what this is set at after the system heats up. This is set for your cold water temperature to make up water. Once the boiler fires up, water expands. Okay, this stops filling. This valve can definitely climb to 40 psi, which is what it's done. Okay, if you wanted to reset this, you would go to the top of the system where it bleeds in, isolate that, bleed some pressure off, and then reset the spring in it. These do go bad over the course of time. It takes a long time, but they do go bad. It's not uncommon. If it does, you have isolation valves on both sides. There's a union. You can spin this off, okay, and replace it if need be. Any questions down here so far? No? All right, I'm going to show you.
Before we go up,
Go ahead.
is there anything they need to do with the strainer? Clean that out?
Yeah, once the job's done, we're going to have chemicals in here, rust inhibitors, things like that. You have mud strainers here. Plus you have a spiral vent here to take air out of the system. We put this hose on here just to keep the place looking clean. The project's done, this is going to disappear. The mud strainers, you can hook a garden hose up to them, blow them down once a year. Once the chemical's in the system, you shouldn't see any buildup in here. You might get a little bit of residual sludge or silt run around the piping system, but it will eventually work its way out here. You have one here and there's one on the other side of the wall too. Okay? If we were retrofitting to an entirely existing system, those things would need periodic maintenance. Okay? Initially, you're going to have a little maintenance on them, but all that maintenance should go away once the chemicals are in the system and everything's up and running. Okay? You have to understand that this project's being done in phases that are stretched out. So you'll have some sediment floating around the system for a little while, but eventually, like I said, it's all going to come out. Okay? Any more questions down here? No? Controls going up. The reset water temperature for the heating system in the building. This doesn't do anything with the domestic hot water. Okay? You have a branch valve, the main valve, and one tracks the other. Whatever one's doing, the other's doing the opposite. So if this one's closing, this one's opening. If this one's opening, this one's closing. Okay? And again, it's based off of the water temperature the mixed water temperature that's leaving this valve. Kevin mentioned that to you earlier. And this valve will modulate to whatever you set that reset graph to. Alright? Once the water mixes through here, it travels out, comes down here, it goes into your main building heating pumps, and heads out towards the system. Alright? Now I just showed you guys the domestic hot water pumps. Okay? I'm going to head over here.
You know, on that stuff, where is the water? Where's the water that goes into a well? Right there.
Temperature sensor's right here.
Yep.
Okay? So if you come over to the sensor, the Viessmann system, the monitors the temperature in the 4 tanks. It's located on the first tank, okay? The other tanks do not have sensors in them. It's very important. If this tank goes down, you need to move the sensor from this tank to a tank that's still online, okay? It doesn't take an average, it only takes a single, okay? You have boiler water going in from the top, coming out from the bottom. Your domestic hot water goes to domestic water. Cold water goes in, comes out, and goes to a mixing valve that the plumber installed. On top of each tank, you have a relief valve, compound gauge, and another hydrant. Okay. Again, these are all maintenance-free situations. There's nothing you need to do on these. All right. There are isolation valves for the tanks. You have to use them. The tanks have all been balanced, so they have the same amount of water going through them at all times. That way we can average out how the tanks are heating. Okay, they're also on a reverse return. First pipe in is the last pipe out. Okay? So as you're moving along, your supply hits the first tank first, but your return is the last return. That way you get even water flow, and then we put the balancing valves in to ensure that.
If there's a problem with that temperature sensor, would that show up down in the boiler control?
Yeah, you would get an error code on that. Is Kevin still here? Kevin? Yeah, if you have a sensor fault, it's going to tell you you've got a sensor fault because the sensor goes back to the Viessmann panel. So when you look at what the domestic hot water temperature is, it'll tell you right here. You can also compare it to what's up here. Okay? In your display screen downstairs, when you log into the set point, you can adjust the set point. If you go to system information and go to domestic hot water, it'll tell you what the tank temperature is. Okay? Instead of what the boiler is set for, it'll tell you what it's actually putting out. I've had phone calls in the past, so we don't have heat. I said, well, wait a minute. Go to the display panel, go to the information, and tell me what you're reading. And you start running down on the numbers. No, everything's running fine. This is all the heat that's being provided at this point in time. Okay. A hot water tank does have simple maintenance to it as far as blowing down any sediment that's at the bottom of the tank. These tanks are different. Usually, domestic water will be in the tank, and the coil gets the hot water. These are not like that. Boiler water is the tank, and the domestic water is the coil. Okay? Once the water's heated, the plumbing contractor picks up the hot water, and over in that back corner is what they call the brain. Yeah, and that's how they monitor the water temperature going. So some of the problems we've had is because we have no domestic hot water, the heating system's down. You know, I put somebody in front of the cascade panel, they bring it up and say, no, you have domestic hot water being produced. The problem is your mixing valve's not sending it out to the building. Okay, it's happened before, so before you say the boilers are broken, there's no domestic hot water, make sure your domestic hot water system's working on the plumber's side. Okay? Any other questions?
What's the scenario where you would have to bypass the three-way?
Well, if the control failed. And if the control failed, what you would have to do is, there's a set of releases on the three-way valve. You'd have to go to the Viessmann panel and unplug the harness for the three-way valve, hit the plungers, remove the valve, and leave it in that position. Now you've got no control over the temperature of the hot water going out. It's going to be whatever the boiler temperature is. Okay? That would be an emergency situation. That'd be something you'd have to have, you know, your in-house heating guy. You'd have to make sure he sets that up correctly. When you look at the Viessmann wiring schematic, it'll give you the plug connector that goes to that three-way valve control. You basically just unplug it, take that relay card out of service, and then come over to the actuators. Come over, I'll show you where that is. There's a release on the side of the valve. You push the release in, and then you can stroke the valves, but you have to do them both at once. You can't do one and not the other. Yeah, there's two actuators, so you kind of need three hands. You need two guys to do it. Each of you would push the button. One guy would push the two buttons down, the other guy would stroke the valves. Okay. You don't ever want to make any adjustments to the way the valves stroke. You don't want to adjust the linkages either. The system tracks water temperature. If you start fiddling around with this stuff, it has to readjust itself. Okay, so it's going to hunt for the values again. There is some lag time in that too. All right. As far as the condition of the rooms is concerned, you want to try to keep these rooms as free and clear of dust and debris as possible. Okay, you have to remember that when the boilers fire up and they're running, whatever's in the air here is what they're ingesting. So, no paint fumes, no detergents, no cleaners, no strippers, no wax, nothing. If you can smell something in the air, that means it's not supposed to be there. Okay? What happens is when you start burning chemicals, you can create resins, you can create acids, you can eat away at heat exchangers by doing that. I mean, it's not uncommon for it to happen. I've had customers, furnaces, not even a year old, and it just crumbles in front of you because somebody spilled a bucket of bleach on the floor and didn't clean it up. And those fumes went through the flame, and when it went through the flame, it turned into acid, hydrochloric acid, and it ate right through the heat exchanger. So yeah, stuff like that can happen. Okay? Any other questions? Anything that you guys feel we didn't go over that wasn't clear and concise? Okay. Now, as a courtesy, I have given my cell phone numbers out to several people on staff. So if you do wind up with problems or something you don't know or you're confused about, you can call me. You can call our office, so get in touch with me, and I'll be more than happy to get on the phone with you. Nothing hurts both parties worse than having you called out for a nuisance situation where it's a 5-minute discussion on the phone. Can save a lot of people a lot of time and money. So don't be afraid to pick up the phone. We're always available. You know, if we feel that it's something that's a little beyond, you know, what you guys should and shouldn't be, you know, playing with or adjusting, we'll send a technician out. Okay? Just please remember, fuses, switches, temperature adjustments, things like that, unless a part's broken, it's not really a warranty situation, okay? So just, you know, make sure you got power, make sure things are up to snuff, you know, before you call us. We'll ask some obvious questions on the way up. Information is always good. Anything that you can give to us over the phone helps us better prepare for the call when we get out. All right? I'm going to go over it. Last thing I'm going to show you is a plate heat exchanger. This is pump 11. This pumps water out of the boiler system through a plate heat exchanger that picks up the heat off the cogen. This is how you get that primary heat off of that cogen. The cogen has its own closed loop fluid system and a cooling system in it. All we do is we transfer that heat over to the heating system, and that's where you get that heat. Everything has isolation valves. No maintenance on the plate heat exchanger. Okay. This pump has grease fittings on it. You'll find them on the back side. Okay. Just when you do come through your periodic maintenance.
Is that the same pump as the boiler pump?
Basically it is, yeah. It's basically the same pump, okay? That's it. I'm going to turn you over to the control contractor now.
All these same guys doing Putnam Gardens too? No?
Some of them are into skill trades on.
Okay, so
Okay.
I work for Automated Building Systems, and name's Ken. I got a card if anyone wants one. We're a control company, but we're basically doing a T-stat job here. I guess we'll get into that later, but after the network and the T-stat, program T-stats and stuff like that, okay? We're just going over the boiler rooms right now. Basically, we have a couple standalone controls that we installed, wired up, all standalone. We don't have a DDC system here. That's direct digital controllers you guys want to know about, okay? What these standalone controllers do is operate the heat and hot water pumps. We got two pumps, P1, P2 I think they're called, or P3, 4, I don't know. We got two domestic pumps for domestic hot waters. We also control the start-stop of those. And we have, we modulate a valve, and we modulate the speed of the VFD pumps, the heat and hot water VFD, to maintain the differential pressure. Okay, so there's basically 4 controls. 3 of them are right here. One you'll see down for the domestic pumps. There's 2 pumps there. There's another one of these pump sequencers down around the corner, right behind on the wall over there. Okay, what the pump sequencers do? Okay, first thing, the heat and hot water pump gets enabled, disabled based on the boiler controllers. When it calls, it tells I want the pumps to run, so this one will actually start one of the drives. Okay? Everyone know what a leak lag is? Maybe leak lag pumps? Okay, usually it will select which one's the lead to run, okay? Then after every week, I think we got programmed for every 7 days, it's going to swap the other one to be the lead. So you get equal run times, equal wear times, okay? No questions? Okay, so what this pump sequencer do is it receives an enable from the boiler, it will start the pump, okay? Now, wired to this is a flow switch, so as long as it's after 30 seconds or a minute, as long as that flow switch makes, everything's grand, okay?
What type of flow switch is it?
It's a paddle, it's a paddle switch, okay? It's mounted, I believe, on one of these pipes here. Okay, I can point it out if you like. Being a leak lag system, shall after a minute or after a while, if it doesn't, anytime it's asking for the pumps to run and that flow switch isn't made, it's going to wait 30 seconds, say, we got a problem, okay? At that point, it's going to send a stop to the lead pump and start the other one, and you'll get an alarm annunciation. Excuse me, alarm lights. I don't think this has any kind of annunciation feature. You get an alarm light, will come on, okay? And I'll demonstrate that, okay? Basically, it's telling you there's a problem, whatever. If the second pump fails, meaning the lag pump that shut down the lead, the lag pump fails, if both of them fails, this thing will start both pumps, meaning you're dead out of water. If you got no power to either pump, at least this thing's going to start it. You're going to, since you have no remote access, you're going to find out from, I assume, a service call, because you got no heat in the building, okay? I think I need a screwdriver.
This is just for these 2 heat pumps?
These 2 heat and hot water pumps, yep. Right there, these pumps right here. Okay, yep, there's another one of these down around the corner for the 2 domestics. They're around the corner there, so, okay? I think you need a screwdriver to get in here. There's a little dial to change how much, I think it's in hours. You should, I had a copy of the O&Ms a month ago when I came here for training. I don't know what happened to that, but so anyways, when you have the O&Ms, you can actually go in here. If you don't like it, you know, every 7 days, you want it every 3 days, you can, it's a simple dial. It's a very simple thing. These have been around since the 80s. So, they're proven or whatever, okay? Basically with controls here, I'll do it for the camera. Basically, we got the 2 heat and hot water pumps that go out to your buildings. Okay, I'm not too sure this is B&B, if it only serves this side, and
or ERF serves the other side. I don't know how it's broken up, okay? So you got supply heat and hot water, return heat and hot water coming back through all these buildings, okay? In between that, we have a valve. This is called a differential pressure valve, okay? And I'll explain what that does in a second, okay? So we got pumps going out. We have sensors here to measure pressure in PSI, okay? What this differential is looking at is it takes whatever the supply pressure is, subtracts whatever the return is, okay? So you get a differential pressure, okay? That differential pressure for your hot water pumps is what this thing tries to control at. So you give this thing a set point, and this thing will modulate the running VFD to maintain that set point. I believe this is set at 15 PSI. I don't know if that's going to get changed once all these sides of these buildings are done and there's water balancing, where the balancer might pick a different set point. But for now, we have them at 15, okay? 15 did work the last winter, so it's okay. It's enough. You might be able to lower that set point for more energy, but it might be more complaints then.
Where are these? Are they in the boiler?
Yes, they are. Yes, they are. They're not 2/3 down the stream now. They're in the boiler room. From here, I think over there, it takes off to every single other building. It isn't like you've got two going out, you know, a steady one. Usually you try to put these two things 2/3 down, okay?
I have problems with that in the past with other jobs.
Yeah, in this location, because you T-tap,
Too many taps.
you T-tap the mains. It costs a lot of money for optimal. If you want to put DP in every single building and to go and average that, that's what we would do with DDC actually, okay? So they are located in here, okay? There's actually two sets of these because these are standalone controls. This one needed a differential pressure, and also the one for the bypass valve. Oh, sorry, the bypass valve here. These are a set of differential pressure sensors. And hot water pumps needs different because we have two different controllers, two standalone controllers.
This controls differential bypass.
Yes, it is, right here, differential bypass. This one is for, also located here.
That's just sets of control.
Okay, the bypass right here, I'll explain in a second what that does, right?
Is that helpful?
No, I know what that does, but
Yeah, that's...
but this is basically.
Oh, thank you. It is going to be higher. It is going to be higher. I'll explain that in a second. 16, you put 16.
Tell me what they are and I'll write it down.
Like I said, those may change because of the balancer, okay? Okay, the balancer needs a balance, and they're probably going to pick a spot, okay? So, differential pressure sensor, right now we got a 15 for the heat and hot water pumps, okay? So basically this controller sends a 0 to 10 volt signal to these two drives to modulate, to maintain that 15 right now, okay? Went down here, and if you hit the right arrow here, it will tell you what the set point is and what is controlling that. And you'll and also say what it's modulating to. Okay? So if you just hit the right arrow, it'll tell you right there. I don't believe you can lock out the programming features on this. I'm not an expert on these Honeywell things. I believe from memory, I don't think you can. So if you got people with a lot of fingers, have a ball, but it could affect something, okay? Okay, so if you wanted to change the set point now, go back home, hit menu, and go into program mode. See the right? See that right? Right there. Okay? George. So, not everybody look.
George, we can't see.
Okay.